Okay, back at Algebra 2, this is section 6.3, and we are going to start talking about logarithms and logarithmic functions. You're going to be taking a lot of notes on this video, I think. Okay, so a logarithm of y with base b is denoted by this right here. If and only if this raised to that power equals that. So really what a logarithm does is undoes problems like that, where you have variables in your exponents. That's what a logarithm's going to do for you. So this right here is read log base b of y. So this would be read log base b of y equals x. Yeah, don't freak out that you don't understand this right away. You're going to understand it by the time we're done with this chapter, I promise. So let's start with this exponential form. 2 to the 4th equals 16. 2 to the 4th power equals 16. The logarithmic form of that, this is the base. That's what goes there. This is the exponent. And this is what it equals. So 2 to the 4th power equals 16. Just remember, this is the base. This is the base. This is the exponent. The exponent. Okay? So log base 4 of 1 equals 0. That's the logarithmic form. Really, this means that 4 raised to the 0 power equals 1. And that's the exponential form. 4 raised to the 0 power equals 1. Log base 12 of 12 equals 1. We know that this is the base. This is the exponent. So 12 to the first power equals this. Logarithmic form, exponential form. This log base 1/4 of 4 equals -1 is really 1/4 raised to the -1 power equals 4. Five squared equals 25 is the exponential form. The logarithmic form would be log base 5 of this equals 2. Remember, this in logarithmic form, this is always the exponent. Another example, exponential form. This is how you would write the same thing in logarithmic form. This is the base. The base goes right here. This is the exponent. The exponent goes right here. And that goes there. Exponential form, g to the 2/3 power equals 4. That would be written as log base g of this Sorry about that, I just realized I had a mistake on here and had to fix it. Let's start over. G raised to the 2/3 power equals 4. If you write that in logarithmic form, log base g, remember this is the base. The exponent goes over here, and this goes right here. This is the base. This is the exponent. So this would be log base 6 of 1 over 216 equals -3. Okay, let's look at, well, a couple rules. Okay, so log base b of 1 is always 0, because remember, This is really b raised to the 0 power, and we all know that anything raised to the 0 power is always 1. Log base b of b equals 1 because b to the first power is always b. A common logarithm is a logarithm that has a base 10. And instead of writing this out, if you see it just written as log, then we know it's a common logarithm and the base is 10. Common logs, there's a key for common log on your calculator. A natural log is a logarithm with base e. You could write it like this, log base e, but it's usually denoted by ln, lowercase l, lowercase n. So now the natural log of x is really log base e of x. These are interchangeable. Like I said, most calculators have keys for evaluating the common and natural logs. Let's talk about inverse properties. So logarithmic functions and exponential functions undo each other. So what does that mean? Well, let's say we have two functions. We have g of x and f of x. If these are inverse functions of each other, then if I evaluate g of f of x, the answer should be x. And if I evaluate f of g of x, the outcome should be x. So they undo each other. So g of f of x would be log base b of b to the x power. That equals x. And f of g of x equals b raised to the log base b of x, and that equals x. We'll talk about how we get all that. That looks pretty complicated, doesn't it? That's just one of the properties of logs that we're going to discuss here in a little bit. Just know that logarithmic functions and exponential functions undo each other. So, okay, so we're going to use, let me pull that back up again. I want you to look at this and this. So if the base and this are the same, then the right side of the equation is going to be whatever that exponent is. If in your exponent there's a log and this base match, then the right side of the equation is whatever is right here. All right? So let's look at simplifying some expressions using what we just talked about. So remember, if this and this match, and the log, the log is in the exponent, then the right side is whatever this is. So remember, this is a common log, right? We don't have to put it there, but there's a 10 right there. And when this and this match, the right side of the equation is whatever that exponent is. Well, this and this don't match, does it? but this is a power of 5. I can rewrite 25 to be 5 squared. And then I can rewrite this to be 5 to the 2x, right? So now this and this match, so I know the other side of the equation has to equal that exponent. When this and this match, the right side of the equation is whatever that exponent is. So if this doesn't match this, rewrite it so it does. And then the next section we're going to talk about is finding inverse functions. You guys already know how to find inverse functions of polynomial functions. It's pretty much the same thing. So you're going to write the original function, switch x and y, and solve for y. So here's my original function. I'm going to put y in for f of x. And now I'm going to switch x and y. And then I'm going to solve for y. So this is an exponential form. I want to write this as a logarithm because I want to solve for that. And remember, anytime you're solving and your variable is in the exponent, you're going to use logarithms. Okay, so this means log base 6 of x equals y. Remember, the right side of this logarithmic equation is always the exponent. And you're done because you have solved for y. You've gotten y by itself. So this and this, those are inverses of each other. One more example of inverse. So here's my original function. I'm going to switch x and y, and then I'm going to solve for y. So I'm going to write this in exponential form. Remember, you can do whatever you want to as long as you do it to both sides of the equation. And what I'm doing here is called exponentiating both sides. So I'm going to go e raised to the x equals e raised to this whole thing. So remember, though, that the natural log is really log base e, right? So just pretend there's an e there. And when this matches this, it simplifies to that, right? When this matches this, it simplifies to whatever is right there. So now we have e raised to the x equals y plus 3, but all I want to do is solve for y. So I'm just going to subtract 3 from both sides. This and this are inverse functions. Those are inverses of each other. And that is it for 6.3. We're going to skip section 6.4. So don't do section 6.4.